Electrical Safety, Comprehensive Guide to Element 10, Paper 2. Welcome to Phani EHS Info. In this video, we'll focus on Element 10, Electrical Safety. Element 10 is all about the hazards associated with electricity and the measures required to control these risks. We'll provide an overview of this element and highlight key exam questions to help you prepare effectively for NEBOSH IGC Paper 2. Electrical Hazards. We begin with electrical hazards. Risks such as electric shock, burns, and fires are significant concerns in environments where electrical systems are in use. Identifying and assessing these hazards involves a thorough evaluation of electrical installations and equipment. This assessment is critical for determining potential risks and implementing effective control measures. Control measures. Moving on to control measures, ensuring the safe installation, use, and maintenance of electrical systems is paramount. This includes adhering to established procedures for isolating electrical circuits and employing appropriate protective devices. Implementing these measures helps to mitigate the risk of electrical accidents and enhances overall safety. Legislation and standards. Lastly, we address legislation and standards. Understanding electrical safety regulations and industry standards is essential for compliance and risk management. Ensuring that all electrical practices adhere to legal requirements is crucial for maintaining safety and preventing legal liabilities. Next, we'll review important questions from this element that you need to know for NEBOSH IGC Paper 1. List the common hazards from electricity. Electrical burns. Electrical shock. Electric arc. Electrical fires and electrical explosion. List the causes of accidents involving portable electrical appliances. Being run over by vehicles. Being dragged over rough surfaces. Becoming trapped in machinery. Coming in contact with hot, corrosive or chemicals or solvents. Continuous flexing. Connection lead get pulled out of cord rips, etc. The making of wrong connections in the plug or other fittings. Poor earth connections. No overload protection being provided. Unsafe work practices, modification by persons who are not competent. Outline how fires could be caused by electricity. How fires might be caused by electricity could be related to causes such as inadequate specification or poor design of electrical equipment and systems. Defective wiring such as damaged cables or loose connections. System faults such as short circuits. Ignition of flammable or combustible materials due to arcing, sparking from switches or motors and static electricity. Incorrect fuse rating. Coiled extension leads. Overloaded electrical sockets generally with multiple adapters. Unsafe modifications to the system such as unauthorized wiring and fuse replacement. Poor or blocked ventilation on equipment leading to overheating and lack of adequate maintenance both of fixed installations and portable appliances. Outline the practical measures to reduce the risk of injury from electricity when using a portable electrical appliance on a construction site. Use of reduced or low voltage equipment. Use of a residual current circuit breaker. Equipment should be visually inspected prior to use to ensure free of visible defects. Apparatus and cables should be protected against overload by fuses and or circuit breaker. All cables should be insulated and protected against mechanical damage. Correct types of sheathing to suit working conditions. Sufficient sockets to minimize the need for trailing cables. The use of a cable drum whenever possible. Correct maintenance and repair of equipment. Correct connections to be assured. Regular inspections and checks to remove damaged equipment. Properly trained and authorized operators of the equipment. Identify the possible effects of electricity on the body. The effects of electricity on the body need to include reference to the cardiorespiratory effects, in particular the risk of fatal injury due to disruption to heart rhythm. Muscular contraction resulting in an involuntary grip on the live conductor, thus prolonging current flow through the body. Tissue burns with the main sites of damage being the entry and exit points with the possibility of damage to internal organs and fractures or dislocations caused by a resulting fall. Identify the emergency action to take if a person suffers severe electric shock. The emergency action necessary after someone receives an electric shock is dependent on the circumstances. Action may include isolation of the victim from the supply, either by switching off or pushing him/her clear with a non-conductive implement. Summoning help. Administering first aid such as cardiopulmonary resuscitation. Treatment of burns and other injuries. Placing the victim in the recovery position and remaining with him/her until professional medical help arrives. Outline 4 factors that may affect the severity of injury from contact with electricity. Current in amperes. Length of contact time. Current path through the body. Conductivity resistance of the body. The voltage. Conductivity of the environment. The nature of the contact. Age, health status of the victim. Explain how earthing can reduce the risk of receiving an electric shock. Provision of effective earthing to protect against indirect contact can be achieved in a number of ways, including connecting the extraneous conductive parts of premises, water pipe etc., to the main earthing terminal of the electrical installation. This would create an equipotential zone and eliminate the risk of shock if a person touched to different parts of the metalwork, liable to be charged at different voltages under earth fault conditions. It is crucial to ensure that in the event of earth fault, the electricity supply is automatically disconnected. In relation electrical safety, explain the following terms: isolation, earthing, reduced low voltage, over current protection. Isolation. Definition: disconnecting the electrical supply from a system or section to ensure safety. Purpose: to prevent contact with live electricity during maintenance. Earthing. Definition: connecting equipment to the ground to provide a safe path for fault currents. Purpose: to prevent electric shock by safely directing fault currents to earth. Reduced low voltage. Definition: using lower voltages, example, 110 V or less, in harsh or wet environments. Purpose: to reduce the severity of electric shocks. Overcurrent protection. Definition: mechanisms that prevent excessive current flow which can cause overheating or damage. Purpose: to protect circuits from short circuits, overloads, and other issues by using fuses, circuit breakers, or limiters. Describe how reduced low voltage protective measure reduce the risk of electric shock and, in each case, give an example of their application. Reduced low voltage commonly used for portable electrical hand tools on construction sites involves the reduction of mains voltage by a transformer to a lower safer voltage, typically 110 volts. Any shock voltage can be restricted to 55 volts by means of a transformer that is center tapped to earth. Additionally, safety extra low voltage, SELV, a voltage less than 50 volts, is used in low-power tools such as hand lamps or soldering irons. Describe how double insulation protective measure reduce the risk of electric shock and, in each case, give an example of their application. In double insulation, Internal live parts of a piece of equipment have two layers of insulation which prevent the exposure of live parts to exposed conductive parts such as the outer metal casing of the equipment. Consequently, an internal fault condition cannot make any part of the casing live. Double insulation is used on Class II appliances, such as hand-held portable appliances and non-hand-held portable appliances such as desk fans and desk lamps. List the items to include on an inspection checklist for portable electrical appliances, e.g. portable electric drill. Appropriate equipment for the task and environment. Equipment is tested on a periodic routine basis. Equipment, plugs, connectors and cables are free from damage. Correct wiring and sound connections. Fuses and other means of preventing excess current in place and correct rating. Accessible and appropriate means of isolation. System not overloaded. Obvious damage to plug, socket, fittings, equipment. Sensible sighting. Used in appropriate conditions. Fit for purpose. No patent defects. Outline a range of checks that should be made for electrical safety in a workplace. Visual inspections for damage to cables, plugs and sockets. The need to ensure that all fuses are of the correct rating. Checking that outlets are not overloaded and cables are not coiled or in vulnerable positions where they might suffer damage. The equipment itself should be checked to ensure that it is suitable and conforms with recognized standards such as CE marking and European standards. That it is properly sighted to avoid damage. That it has been subject to appropriate and regular fixed installation and portable appliance testing. That it is provided with means of isolation after use and records are kept of the maintenance that has been carried out. Checks should also be made to ensure there is an effective procedure for reporting defects or damage. Identify the factors that would determine the frequency of the inspection and testing for a portable electric drill for use on a construction site. The factors that might affect the frequency of inspection and testing of the portable drill include but are not limited to the following. The nature of the work. The environmental conditions in which the drill is to be used. The frequency and duration of use. The age of the equipment. The intrinsic safety features of the equipment such as double insulation. The use of low voltage. User checks and the number of problems reported. The number and competency of the users. Manufacturer's recommendations and best practice guidance. The results of previous tests and inspections. Identify safety features of the brush cutter that will reduce the risk of electric shock to the user. Safety features of the brush cutter could include its voltage, preferably 110 volts. It is Class II double insulated and has a waterproof casing. It is used in conjunction with a residual current device, RCD. It is properly earthed and provided with a mains cable of robust construction and is fitted with a fuse of the correct rating or connected to a circuit breaker. Other than electricity, identify additional hazards associated with the brush cutter that the user could be exposed to. Additional hazards faced by the user in clearing the undergrowth could include contact with the moving parts of the brush cutter such as the rotating blade. The possibility of being struck by flying stones or other material. Slips, trips and falls, for example, caused by contact with the trailing cable. Manual handling hazards. Exposure to noise from the operation of the motor. Vibration through the handles of the machine. Dust and biological hazards, for instance coming into contact with animal waste. Other than electricity safety features, outline the control measures to reduce the risks to the user when operating the brush cutter. The control measures to reduce the risks to the user of the brush cutter include the selection and maintenance of equipment to reduce to a minimum the levels of noise and vibration, restricting the time spent on the operation, ensuring the guards were correctly positioned before starting the work, the use of a hold-to-run switch, the provision and use of ear defenders, eye protection, dust mask, gloves, safety footwear, gaiters and high-visibility clothing that also afforded protection against the weather, and the provision of information, instruction and training on the hazards associated with the equipment and the control measures to be observed. Outline additional control measures to reduce risks to other employees who may be in the vicinity of this work. Additional control measures necessary to reduce risks to other employees who might be in the vicinity include advising them that the work is to be carried out, cordoning the area with barriers and/or tapes and erecting warning signs, providing alternative means of access around the work area, protecting the cable route, carrying out the clearing operation, if possible, outside normal working hours, using a standby person to deter other employees from entering the work area. Thanks for watching. For important questions and answers, and to learn about the remaining elements of NEBOSH IGC, please subscribe and follow my channel.
This is all about today's topic. Thanks for watching Phani EHS Info. And don't forget to subscribe our channel to get immediate notification of our videos. Share our videos to your friends and colleagues to create safety awareness. If you have any questions and requirements, please comment in comment box.